So let's start. Any problem, any question to get access to the server, your virtual machine, just email me or Brad or Patrick and explain what's the issue, please.
I think the only ones who have are people with this. I think we're the only ones who have access to it.
So the rest of the class, I think that there's some admin problem, so let me provide the feedback. That's great. So suppose that we do have access to our instance. Okay? So I do have another virtual machine in other labs. Let me remember the IP address. Okay. This is my other virtual machine on the lab. So this is the same as what we have in ACE. I'm involved in a lot of projects here, such as big data, machine learning, TensorFlow, and some Udacity courses. When you want to start implementing the code, it is really important to understand what's the goal. At first, define your goal and then go for your work. For example, for machine learning, at first, you should understand which algorithm is appropriate for which type of. Yes? For example, let's go for Udacity. So there are a bunch of algorithms that provided here. Actually, I will implement some of them, and I'm working in the rest. For SVM, I prefer using Python nowadays. We are so what is SVM stands for? SVM stands for what? Support vector machine. It's a method that you can classify your data, play with your data, and get the final decision. Oh, this data is for what? For example, there is a project in anomaly detection. What is anomaly detection? Can you guess, please? Something is different from the rest of the data. Okay? So, finally, you should categorize your data. Okay, my data is in these classes. For example, you do have a robot that wants to distinguish between the exit door and the rest of the room. How you can do that? One of the ways that you can do that is getting the EEG, yes, the brain waves, and just make a categorization of the EEG signals. Okay, when the robot, when the human is looking after the door, the EEG signals are in that type of shapes. It is not an easy way. First, you should provide a lot of sensors around your head, get the data through each channel. Each channel is for sensor. Then you should categorize that data. Okay, when I'm looking at door, my brain is reacting something just like as this. And you should make a sample of them. So in that case, you do have a big matrix of the information and you should handle that bunch of information. Okay. So, but reaching to that point, is not the one step. At first, you should start to typing, play with the codes, understand the code, understand the capability of the codes, and so on. So, let me move back to my virtual machine. This is my virtual machine here. The first, the interface that I'm dealing with that here is the command line. Somehow it is getting some hard to get access to all of your data. There are features that are provided by IPython, the new version is Jupyter. It's some kind of notebook. That can get the information from your virtual machine and play with the codes. Then I should come back to my browser. Here, go for local. So this is my virtual machine. I do have access to all the files that is provided, that are provided in my virtual machines. Let's go for the Udacity, for SPM, and my IPython codes. This is my Python code, so I can transfer it to IPython easily. Just by typing. And then run it. So, what's the advantage of IPython? IPython provides you with the view of what's going line by line for your code. When you want to write your code in Python, it's a bunch of lines here that you cannot make a distinction between. But when you convert that to Python, actually when you want to see this is it. So, if I want to manipulate the code which I provided, it's going to be hard task because always I should take a look at it, so you know what's the problem comes from, I should run it, but you know I don't have access to run it as same as MATLAB line by line. It's a Python kernel. So Jupyter helps me to control line by line codes. Let's take a look at this Python code. What is it about? This is one of the codes that provided to handle the classification of the data. When you are talking about machine learning, you do have two major categories, supervised algorithm and unsupervised algorithm. Do we have other kind of algorithms? Yes, we do. Reinforcement. Okay? And semi-supervised algorithm. But majority of them are supervised or unsupervised. SVM is a supervised. So we train our data to provide the output to classify the rest of the data. As you know, guys, Python provides us with a lot of libraries. We import some of them here at the time. And this is the codes that provided to distinguish the spam emails from a bunch of emails. How we can do it? It's easy because each person is using the specific words in the email, in each email. Okay? But spam emails contains the common words. So if we statistically study the words in the email, then we understand how much this email is related to the spam emails. We can make a decision and notify the receiver, okay, this email seems to be a spam email. For example, in this example, there are two guys. We have a bunch of emails that we don't know it is from who, but we do have access to the inbox, to the sent email of these two guys. Okay? We train our algorithm to understand if this structural word and sentences is using in this email, it's related to Abby. If not, it's related to other ones. For example, Lori. Okay? To do that, there are some few steps. When you want to play with the machine learning algorithm, you should at first understand what is going on inside of the algorithm. It is not necessary to understand every detail of the math part, but the whole construction of the algorithm and how you can use it. One of the family's library that helps a lot to do that is the scikit-learn library. It's dedicated to machine learning. As you can see, there are a bunch of classification of the algorithm here: regression, classification, clustering, pre-processing, model selection, dimensional reduction, and so on. Suppose that if we go for the classification, bunch of algorithms are sorted here. Bridge regression, logistic regression are the most famous ones in the linear model. Quadratic models are going to be some other algorithms. And nearest neighbor. For example, we should understand how we can get benefit from the nearest neighbor algorithm. Okay? Then we should take a look at it and see how we can implement it. In the supervised algorithm, at first, we should train the model. What is the model here? For example, nearest neighbor. In the SVM, it's the SVM. So, come back to the code. We import SVC because the library of the SVM, the whole library of the SVM. Then we make the CLF as a classification. We define the model here. The model has two important parameters. We should define them at first, kernel and the C parameter. Then we should feed our model with our trained data. How we can find this trained data? Here. Train, test, train, test. We have a feature train, we have a label train. Each train data has a label. Okay? For example, this email, this category of words are related to the admin. Okay? We label this email. We label other email, this category of words is related to Lori. Okay? Then, what should we do? We should test our data. With what? With the test data. And then we should compare that. Okay, how much accurate is our algorithm, is our model? So we should compare our output with the test data, with the label of the test data. Then after fitting, actually training the algorithm, we predict it, then we're gonna compare the accuracy of our algorithm. What is the accuracy of our algorithm? Okay? And then we can get a bunch of information out of the data. So, any question for that? The steps are implementing the machine learning algorithm. If you do have a project in this area, that's first. Find out your data set, understand what is your database structure is. Second, you should choose the appropriate algorithm for your data set. Based on what? Searching the internet. For this kind of email, there are two most famous algorithms that are very good. Naive algorithm and SVM. So I'm going to implement these two types of algorithms. How they work? Search more. Scikit-learn provides you with a general description. If you need more, just search through the internet and get more information. Then come back to the machine learning free library source by Scikit-learn and understand how you can implement the algorithm with the command in Scikit-learn library. First, fit the algorithm. Second, get the prediction. At last, estimate the accuracy of your algorithm. Then, if your accuracy is much more than the others that is announced in the literature or in the internet, then you can sell your algorithm. Okay? So, this is the one of the application of machine learning implementation in the cloud. Let's run our code and see what's going on. Here, since I just import my code, in the IPython, it is not line by line. So let's run it. It's a whole model. It is working. So, if you want to run this type of things in your local machine, it takes a lot of time. But you can see that in the cloud, it takes just a few minutes to complete it and provides us with the output. Number of queries training email is around 8,000. Number of startup training emails is the same. Training time, prediction time, accuracy. 97% the algorithm is accurate. So it's really good, but not so much. In machine learning, if you want to claim that our algorithm is good, in some application, you should have more than 99% accuracy. In some others, it is just enough to have 80% accuracy. Okay? Okay. Let me provide you with the general view of the R versus Python. Okay? The source of this is this website. So you know that when you want to present something, you should always find it. So this is the website that will provide a good comparison between the R and Python. Let's dive to what is interesting for us actually. Who is working with R? Actually, what is the goal of R? In R, it is trying to provide you with a simple one-line command that handle all the things that you need. For example, in Python, when you want to get the data manipulation or outputs of your algorithm, you should write a couple of lines, not so much, but in R, it is trying to reduce the lines number. So, purpose, R focus on better user-friendly data analytics, statistics, and graphical models. It is what it is a really, really good point of R, because later on I show you what is the how we can get the advantage of R by just running the RStudio. So Python increases productivity and code readability. You know, the advantage of Python is that if you just know a little bit about Python, you can understand what is going on inside the code. But in R, always you should refer to your reference to understand this line, because it is so compact line. You should always refer to your reference to understand, okay, this line is doing this type of functions, all them together. So Python is generally used by everybody, especially engineers. Okay, so R is not, you know, or it's getting better, but not as well as Python. The other thing that is interesting for me is the income. The income of Python and R. The average income of Python guys are around 95,000, but for the R guys it's going to be 150,000. So you can see that R, maybe it is time consuming, but you can get the benefit of the income as well. And popularity of R is not the same as Python, but the major reason is that Python is really, really easy to understand. So there are some libraries that are available for both R and Python, and you can see for Python it's much more than the R. Actually, Python is the language that is used for OpenStack. You know, the Python is the cloud language nowadays. Not only Java or C, but Python. And if you invest the time on Python, you can get the benefit later on. So, the other things in the cloud that is really important for you guys. So the aim of me is provide you with some hint that helps you to follow in your future education, job, or your research, or everything that you need. So far, we discussed about the cloud. Now we are discussing about how we can get the advantage of the cloud. Robotics was one of the applications. Machine learning and big data is what we are discussing about it now. What kind of language you should use, or Python, are the languages that helps you to implement a really, really strong code. And the question here is that how we can show your code through GitHub. Have you heard about GitHub? Yes. As an engineer, nowadays all of us should play with GitHub. And what is the advantage of GitHub? What's that? sharing the code. Sharing the code is a free source. Everybody can contribute in the code. So this is already big advantage of the GitHub. But how we can get the advantage in the cloud? It is really, really easy to use. Just by typing some command, you can get the code through the internet in your local machine and then manipulate the code and publish your own code through the GitHub to others, to us, professors. So I want to just jump to GitHub and just try to introduce you how you can get the advantage of GitHub. So this is my account. Big data and machine learning is a project that I'm working on that now. So actually one of the projects that I spend a lot of time on that. For example, name-based algorithm. I provide my code here and you can get access to the code and see how we can implement name-based algorithms really, really easy. Okay? But let's come back to this library and I want to show you how you can have that code in your local virtual machine. The first thing, this is the address I provided and always you should refer it. If you want to use other libraries, for example, other guys, at first you should forward that library to your GitHub account. So I just copy that in my clipboard, come back to my virtual machine in the A-Suite lab. It was here, yes? It's live. There's a really good command line here, bit. I don't have it. The first thing is I should install it, yes? Apt get install Git. Okay, the administrator doesn't permit me to do that. So I just come back to my other machine to show you how it works. So this is my other machine here. This is my kids. These are the bunch of command that helps me to understand how I can get benefit from the Git if you type it. And if I want to get the version of my Git, just type version. So my version is 1.9.1. It's almost updated. Let's clear it and come back to the page. So you can see I do have big data and machine learning document works here. This is the first, this is the same as what I have in my cloud, in my GitHub account. Without any worries, let me at first remove it, -R, because I'm removing the folder, so I don't have it anymore. But I check, I do have Git in my account. I just get the address that I copied in my clipboard. So I clone it. I do have it down again. Just jump to that. This is my URL. Away. These are the files that I have in this. Let me make a list of them. ML algorithm. I try to provide a description of algorithms to be helpful for other students that come to our labs. So And the interesting project that I'm working on that now is a shoe project. I'm trying to implement neural network on top of the shoes to figure out what is the kind of the shoes. Let me come back to my local machine. My home, big data, Romo, this guy. So I'm using IPython not only for implementing the code, but for producing the report as well. So at first I tried to explain, okay, this is my code, I'm going to implement neural network in the convolutional method, and then this is the method that I'm using, this is the steps that I'm following, and I can have the math here as well, you know, it's a math. That's it, as same as LaTeX, if you are a LaTeX guy. Then these are my data sets. I try to manipulate the data sets and get the kind of the shoes and many others features. Let me come back here to my local machine. This is the data set that provided by Yahoo, okay? So it's a really good data set. We do have samples. This is the company. This is the classification, for example, here. This is the sample type. And let's see, for example, this is the Nike. Let me go for the Nike. Samples, something just like that, or Michael Kors kind of shoes, you know. And my aim is categorize these shoes. For example, this is the brand of Michael Kors, and this is the woman's shoes. It has a hood. Or this is the sandal for the woman or for the guy. So you can see, let's see how much information is in this folder. It's about 162 meg. But in the real world, when you're dealing with Amazon or Yahoo or other providers, it is about more than 1,000 of terabytes. So handling that kind of information, implementing the algorithms, as I mentioned, such as SVM, in Python or in R, require a lot of time. The last things I want to show you guys, it was the last session I know, so the last thing I want to show you guys is RStudio. This is R, and this is one of the interface RStudio that you can get advantage through there. For example, I remember this is the code that I provided actually for previous semester for my course. So you know that here we have the test and train data as well. Suppose that this is our test data. R provides a good vision of the data. You know, in Python, you should always play with that. Okay, this is my data. This is the structure of my data. Blah 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 blah. But in R, you do have a vision of how you can play with your data. This is my test data. This is my train data. Okay. This is BWT. Actually, BWT is the kind of graph that you can provide not only the mean, but the variance of your data as well. So all of them can be provided in R, and it is really user friendly. This is the package that you can add them as same as Python. You import the package and you use it later on. So I try to provide you the general understanding of cloud. Now how you can make your instances, and then there are a bunch of tasks that you can implement. Machine learning, robotics, big data analytics, all of them. And I'm trying to show you Jupyter is a good interface if you are getting confused when you're dealing just by the command line. Okay? Two kinds of programming are described, R and Python, the basic one, the general view, but each of the topics that are presented today require a semester to go through them. That's it.
Any question?